Hello students, today's agenda is to check homework. We'll be learning proofs of midpoints and you will be able to work on 11.6. And today students will be able to prove statements involving midpoints. So we're going to start with this information. So pause the video and copy it, or first watch and then you can pause it. So it says prove that the diagonals of the rectangle below bisect each other. And so I asked in class, what does the word bisect mean? And also diagonals. And so bisect means to cut into two equal parts. And the word diagonals refers to any line connecting two vertices that are not adjacent to each other or next to each other. Okay, so this will be a side, but then this will be diagonal. And there are other shapes that you have more than one diagonal going from one vertex. For example, in here, this is a side, but then you have this diagonal and this diagonal going off from this vertex. Okay, so those are diagonals, any line segments connecting vertices inside of the polygon, basically. Okay, having that information, he says prove that the diagonals of the rectangle below bisect each other, meaning that so this diagonal cuts this other one into two equal parts. This section and this section should be equal. The same for the other one. This line bisects this other diagonal into half, meaning that this is congruent to this part, but we have to prove it. And what we're going to be using is the midpoints. So if you recall, the formula for midpoint is equals to find the x coordinate is x1 plus x2 divided by 2, and then y1 plus y2 divided by 2 to find the y coordinate. And so we're going to start by finding the midpoint of line segment AD. So the midpoint of AD, line segment AD, is going to be found by adding. And so in here, I'm going to go ahead so that I don't get confused. I'm going to write the point of A, the coordinate, so it's 0, B. And the coordinate for D is A, 0. And remember that this is x1, y1. This is x2, y2. Remember that it's because it's point 1 and point 2. It's just basically labeling them. And so my x1 and x2 are the first two numbers or letters in this case, 0 plus a divided by 2. And for y, I'm going to add the two y's, so this one and this one, the second number or variable on the coordinate. So b plus 0 divided by 2. I simplify that, and so my answer will be 0 plus a is a divided by 2. B plus 0 is b divided by 2. So that's the first coordinate. Now I'm going to go ahead and do the same for diagonal CB. So find the midpoint of line segment CB, and we're going to use the same formula, and the point for C is 0, 0. The point for B is A, B. And so I start to substitute into the formula my two x's, meaning the first two numbers in here or variables. So it's 0 plus A divided by 2. That's for my x. And for my y is 0 plus b divided by 2. I simplify that, and so 0 plus a is equals to a divided by 2. 0 plus b is b divided by 2. So I notice that we have the same midpoint for both of these diagonals. What does that mean? That if they have the same midpoint, this point is in the middle of both diagonals, therefore they are bisecting each other. Okay, so this is what you're going to be working with for 11.6. That's basically all you need to do. And if the two appear to have the same x and the same y, that means that they have the same midpoint. If they are not the same for even one part of them, then that means that the midpoint is different, and therefore that they do not bisect each other. Okay, so you're done. This is all you need to see. However, if you've been confused with the past few lessons, I'm gonna go ahead and summarize what you've learned with the midpoint, the distance formula, and the slope. So we just saw the midpoint, and the midpoint, the formula is m equals, and you have x1 plus x2 divided by 2, and y1 plus y2 divided by 2. And basically that means that with this formula, if we have a line segment, we're going to be able to find the middle of that line segment. Okay, that's what it's going to tell you. And in here we notice that it helped us find midpoints of diagonals. Okay, so I'm going to put in here that this has up to now has helped us find midpoints of diagonals. Okay, to see if a midpoint is shared, and this means bisecting the diagonals. Okay, so that's what the midpoint has done for us in this lesson. In the previous lessons, we also learned the distance formula. And so it was d is equals to the square root of, remember we put the two parentheses with the 2's in there, and then a minus and a minus. And then in here said, so that you will relate it to the slope, which I'm going to explain right next, I just put y2 minus y1, x2 minus x1. Okay, and the distance formula, what it helped us do was to see if line segments are congruent. For example, in rectangles, opposite sides are congruent. In squares, all four sides are congruent. Let me see what else. In rectangle, parallelograms, opposite sides are congruent. So those are the kind of things that you can see with the distance formula. The other one is the slope. And the slope, the formula is m equals, notice how for the midpoint it's a capital M, for the slope is a lowercase m. M equals y2 minus y1 over x2 minus x1. And so the slope helped us because if, okay, I'm going to share in here to see if lines are perpendicular, like in squares where you have right angles, right? So this is perpendicular to this line, meaning that they form 90-degree angles. Or it can help us to see if lines are parallel, or to see if lines are parallel. And although we didn't see much of this, for example, in trapezoids, if the slope of this line is the same as this one, same slope means that they are parallel, therefore it means it's either a trapezoid, or we might have a parallelogram because this is parallel to this line and this is parallel to this one. So if the slopes of two lines, we prove that they are the same, then they are parallel. If they are, for this one, if the slope is opposite, reciprocal, whoops, I didn't fit it in there. Opposite means opposite sign. Reciprocal means you switch the numerator and denominator. Okay, so basically, if one line has a 2/3 and the other one has -3/2, then that means that they form 90-degree angles. Okay, so that's what these three formulas have helped us in these couple of last lessons. Again, I'm summarizing just because I've noticed that students know how to do it at the moment, but then they're not sure what's going on, and so I hope this summary helps. So the midpoint, to know if the two diagonals bisect each other. Okay, so it's right, they cross exactly in the middle. The distance, to see if the sides of certain figures, like the square, these are all congruent. If they are the same distance, that means that they are congruent, and therefore it might be a square. Also rectangles, this is congruent to this side and this is congruent to this side. Or parallelograms is similar to the rectangle. This is congruent to this side and this is congruent to this side. Notice how congruence is with two straight lines. Parallel lines is like two little arrows or one little arrow. Okay, so the markings are a little bit different. And so I hope this helps, and have fun doing 11.6.